parts box the other day as I was cataloging whatever I had here. And I came across this very old package, which I bought probably in the late 80s from Radio Shack, um, and never really used it. It is the VCP-200 voice recognition chip by Archer, which was a subdivision of Tandy at the time. So I got really excited about this. I had completely forgotten about it, and decided to see if I could adapt it for use with my Texas Instruments TI-99 for a computer. As you know, the TI had a peripheral called the MBX expansion system, which was made by Milton Bradley, and it allowed the use of speech with a select few games. It's currently a fairly rare expansion, and it's quite pricey. The main difference between the MBX system and this chip here is that the MBX system is a speaker dependent voice recognition system, which means you need to train it every time you use it, whereas this VCP-200 voice recognition IC is a speaker independent voice recognition chip, and it only recognizes just a few words, but these are stored permanently in ROM inside the chip, and therefore there is no training necessary. Again, the main limitation of a speaker independent voice recognition chip, at least with the technology of the 1980s, was that it was limited to only select few words with no variation, whereas with something like the MBX system, you could use different terms for different actions every time you train it. That said, let's take a quick closer look to that at that chip. So it is the VCP-200 from Radio Shack, and what it is actually a Motorola microcontroller, an 8-bit microcontroller, which had about 1.5K of user ROM and 30 bytes of RAM. So what I believe Archer did is essentially store the voice recognition algorithms as well as the comparison data into the ROM, not a mean feat for 1.5K only, and essentially presented us with a finished product. Now the main package consisted primarily of the chip and a applications data sheet, which essentially had a brief description of how the VCP-200 worked at the high level. There were no real explanations on how the actual processing of the voice was done, and no internal details of the microcontroller itself. And also there was a brief theory of operation and a PCB schematic, as well as an electrical schematic, which allowed you to set up the support circuitry needed by the VCP-200 in order for it to work. Now this chip only recognized essentially a very small subset of voice commands. In one mode it recognized 5 words, which were go, stop, turn left, right turn, and reverse. And in another mode it recognized yes, no, on, and off. So with that limited vocabulary though, for the 1980s anyway, you could do quite a bit of stuff with robotics and such things. Now, as far as my interest for using it with the TI, the main thing that came to mind, of course, was can it be a replacement for the MBX system, and I figured that there should be no issue, hopefully, controlling the joystick port by connecting it to the outputs of the chip when it responded to voice commands. But first and foremost, I needed to first test it out and make sure that it actually works as advertised. So here's the breadboarded VCP-200 with its support circuitry. On this side here we have the amplifier circuit, which amplifies the voice coming through this very old electric microphone, which I actually found at my local Radio Shack recently. And the heart of that amplification circuit is an LM324 op-amp chip. And there are two stages of amplification, giving you, according to the data sheet anyway, up to 800 times amplification. And then one of the op-amps on the chip is used as a comparator, which is used to actually clip the voice waveform in order to create a crude analog to digital output, because the VCP-200 only accepts digital inputs and does not have an analog to digital converter on board. Remember, it is a very primitive old microprocessor. So on the right hand side we have the actual VCP-200 with its basic connections per the schematic. The LEDs each represent one of the 5 available voice commands. So I'm gonna go ahead and put the power on, and it takes 5 volts, and I'm gonna get the speaker very close to my mouth. It needs to be within 1 inch according to the specifications, and we'll see how this goes. You should see one of the lights, the LEDs, actually light up with each voice command. If it does not recognize a command, sometimes it will just pick the closest command that it knows and light up that LED accordingly. So you need to essentially avoid as much as possible background noises. So here we go, let's give it a shot. Left turn, stop, go, turn right, reverse, left turn right, go, stop, reverse. So as you can see, it does work. So from there on, it should not be too hard to connect these LED outputs, to replace those LED outputs with connections to the joystick port. And what I'm going to use is, at least for experimentation purposes, is this breakout connector, which is a DB9 connector, with essentially its inputs broken out for easy access. And I use it to connect these LED outputs to the TI-99, and then create a small demo program to see if I can get it to work appropriately. So more to come. Okay, so I have the circuit connected now to the TI-99 for a computer. I have added one chip right here, which is an LS74LS125, which essentially allows me to connect the joystick lines to the joystick select lines on the TI. And that was an idea brought to me by Stuart, so thank you, Stuart. I'm using this adapter here. It's just DB9 adapter, which breaks out the joystick lines for easy access. And so we're gonna go ahead and see how this works. Essentially all it's doing is anytime I say a voice command, one of the output pins on the VCP-200 goes low, and that triggers the appropriate joystick line. I'm going to do a test, a very simple test with TI invaders. This will work with really any program whatsoever that uses joystick lines. The only thing that will be sometimes awkward is that the commands may not necessarily match the action on the screen. For example, going up would be something like go, going down would be reverse. If you can live with that, then this system will really work well. Of course, one can also create their own programs to fully utilize that voice recognition system. So let's see how this works with the Texas Instruments TI-99 4A Space Invaders. So here's the system, and here is the the Space Invaders. I'm going to go ahead and zoom in a little bit on the action here. As you can see, as I'm talking, the microphone from the voice recognition circuit is picking up the background noise and will trigger the action at random. So here it triggered the start of the Space Invaders game. So that is something we need to be aware, especially if we're using this system in a noisy environment. So let me go ahead. Alright, so let's give it a shot. I did rig up a joystick switch here. In case I wanted to fire back, but we're going to primarily test the voice recognition here with the Space Invaders. So here it goes. I'll go with merely aggressive. Turn right. Stop. Left turn. Now that didn't last long. Turn right. Stop. Turn right. Left turn. Left turn. Stop. Turn right. Okay. Well, it does work. I suck at it, but it does work. One more shot. Left turn. Oh man. Turn right. Stop. Left turn. Stop. Left turn. Stop. Turn right. Turn right. Left turn. Turn right. Left turn. Stop. Left turn. Stop. Now if you notice, there's a little bit of lag between the voice command and the action on the screen. So that makes it a little bit tricky with action games like that. Anyway, you get the idea. I'm going to go ahead and try Munchman, see how that works. I haven't tried that before, so let's see. I'll just replace the cartridge here. Alright. One thing I did, I forgot to put the sound on. So, let's do that. I wonder how the sound will work, will interfere with the recognition. We'll see. Reverse. Turn right. Reverse. Oh, yeah, this is gonna be hard. Turn right. Yep. Alright, give it another shot. Go. Turn left. Yeah. Turn right. Jeez. Reverse. Turn right. Yeah, this is definitely not playable in voice command. Way too fast. Turn left. Reverse. Turn right. Go. Turn right. Go. Yeah. Just not responsive enough for the game, for this type of game anyway. In any case, it does work. I don't know if it necessarily replaces the MBX system, but it's certainly an alternative. Particularly for slower paced games, it may work just fine. I'm actually going to go ahead and try a few other games subsequently just to see what works best. In any case, this is it, so I hope you enjoyed it, and let me know if you have any comments about this. Thank you.